Okay, well, if we solve f of x equals 0 and the two solutions are imaginary numbers, how many x-intercepts will it have? Well, remember, solving f of x equals 0 gives the x-intercepts. So if they're both imaginary, that means there's none. And let's just visualize what that might look like here. So if I have an xy plane, there's like three scenarios of how a parabola can intersect the x-axis. The first one would be what we often see, where the parabola hits in two spots. So normally we're going to get two real solutions to f of x equals 0. If we happen to just get one, sometimes this parabola, the vertex can just come down and kind of kiss at the x-axis, then there's only one solution. So one real solution to f of x equals 0. You know, the parent function's a good one for that, like f of x equals x squared. That's an example of one where it just hits the x-axis. Then we have the last scenario where it's just either above or, you know, possibly below, like this, where they don't hit the x-axis at all. And this is the scenario where we get two imaginary solutions, f of x equals 0. So that's just the connection between solving these quadratic equations and what the graphed parabola might look like. So again, there's scenario 1 where you get two. Those are both real solutions. Scenario 2 where you just get one solution, and here where we get no solutions. Solve these equations. So these are just going to turn out to be quadratic equations, but we have to do a little work to get there. Here I'm just going to cross multiply. So x times x is x squared, 5 times 10 is 50. And then we solve this by square roots. Take the square root of both sides. And that equals plus or minus the square root of 50. Square root of x squared is just x. We can rewrite this as 25 times 2 with that perfect square factor. X equals plus or minus 5 square roots of 2. This next one, just got to collect some like terms. I'm going to subtract 3x squared from both sides. I'm going to subtract 5x from both sides, and we'll subtract 15 from both sides. We do this on the right, we've chosen all that so that we get a nice 0 there. 4x squared minus 3x squared is just x squared. Minus x minus 5x is minus 6x. 20 minus 15 is 5. And now this is a nice, familiar looking triangle square kind of problem. What two numbers multiply to 5, but add to negative 6? Well, we know negative 5 and negative 1 will fit that bill, so we can finish factoring this. X minus 5, x minus 1 equals 0. And then apply the zero product property. X minus 5 equals 0, or x minus 1 equals 0, x equals 5, or x equals 1. Alright, so here's just a simple graph the parent function for the parabola. So to make this the x-axis, make that the y-axis. We know the parent function centered on x equals 0, so I'm going to go ahead and just do a few points to the right here, including the vertex. So all we're going to do is take these numbers and square them. So 0 squared equals 0, 1 squared equals 1, 2 squared equals 4. So these are the three coordinates I'm going to graph initially here. So 0, 0. This one is 1, 1. This one is 2, 4. 2 over 4 up. And that's going to give me the right half of this parabola. And then we can use symmetry, since we know that parabolas are symmetric along the line going through the vertex, well, we know this point is going to be here due to symmetry, and this point will be here due to symmetry. So we don't even have to do the table to get that, finish drawing this parabola that way. And so this is the parent function f of x is x squared. All right, for each scenario, write the equation of the quadratic function that shifts as described below. Well, let's just remember what the standard translation. So in vertex form, we learned that x minus h squared plus k will do a horizontal shift of h units. It's horizontal, and a k or vertical shift of k units, where if h is less than 0, that means left, and if k is less than 0, that means down. Okay, so for a here, we'll start off with f of x equals x minus h squared plus k. Well, 1 unit down means that k is going to be negative 1, and 1 unit to the left means h is going to be negative 1. So we'll just do f of x equals x minus a minus 1 squared minus 1. This will be x plus 1 squared minus 1. Four units to the right only, well, that means h is going to be 4, but k will be 0. So we can use f of x equals x minus 4 squared. Again, that's what the h is, plus 0, which I can just simplify as that. I don't need to add the 0. And c, 10 units down, that means h is going to be 0, no horizontal translation, but k will be negative 10. So for f of x will be x minus 0 squared minus 10. But x minus 0 squared is just x. So x squared minus 10. So these are the three different answers for question 11. Number 12, write the equation of the function that transforms the parent function by reflecting it. So it's going to do something like this. Frown into a smile, or smile to a frown. Vertically shrinking it by a factor of 3. So shrink means divide by 3, or multiply by 1/3. That's how we shrink something. We multiply it by something less than 1, and moving the vertex to the coordinate 5, 6. All right, so there's three things that are going on here. So we know that a at first is going to be negative 1 or 1/3 because of the shrink by a factor of 3, but it's actually going to be negative 1/3 because we need to reflect this graph as well. And that's how you reflect it, is a becomes, you change the sign of a. So now this is going to be a downward facing parabola that's shrunk. And then if we know that 0, 0 moves to the coordinate 5, 6, this will help us we'll be able to get h and k from this, because 0, 0 is going to move out to the point 5, 6. So here the horizontal shift is going to be from 0 to 5, so h will be 5. And 0, the y-coordinate of 0 is going to go up to the y-coordinate of 6, so k will be 6. And so now we have all the pieces we need to write this equation. Again, I'll just write the generic form. This is our generic vertex form parabola, where we can interpret these parameters as the horizontal shift, vertical shift, then the vertical stretch or shrink factor, knowing that if it's negative, it's also a reflection. So we'll just plug in our numbers that we've determined here. 1/3 x minus 5 squared plus 6. So this is the equation of the parabola that does all those things mentioned in the question.